Hello everyone, my name is Ahmed Atamli. I'm a security architect at Mellanox Technologies, and today I want to talk to you about guarding assets in edge platforms. Why edge security? Edge devices are different than data center devices. The two environments are massively different. In data centers, we assume that the machine is locked, the building is guarded, and you don't have as much physical access. While we can't make the same assumption about edge environment. Who is the threat? The threat could be the user. If the edge is deployed at the user of the user, then I have the user of the user being another malicious actor that can attack my system. It could be a malicious administrator. Whoever have physical access to the machine can do a lot of damage and compromise many of the security measures. And we have a lot of security measures today in place to protect these systems. Security measures like secure boot, measured boot. We have write protect in order to prevent malicious activity from changing the firmware of the BIOS or the firmware of the NIC device or any other asset that I consider dear and need to protect. If I have a physical access to the platform, there are many attacks that can be performed. And in this slide, I'm capturing some of the equipment that can be used to compromise many of the security measures that we have in place. On the left side, on the upper left side, there's a chip device that can be inserted, that is inserted on the motherboard. There are two types of attack that can be done. This can be classified into two types: integrity and confidentiality. And the integrity part, the aim is to compromise the platform in a way that I can run my own software, change the code, change the firmware, disable the security, and this can be done in various ways. Whether I insert a chip on the motherboard, whether I disable the write protection that I have and my storage device, either I inject laser on the processor that is doing the execution to cancel the security measure like secure boot and the authentication, whether changing the frequency in order to skip the cycle that is doing the comparison between a success and a failure. But an edge device it's not only about the integrity, it's also the confidentiality. Because edge devices also operate in users' data, and in order to protect the data, I need to use cryptography and encrypt this data when I send it over the network or store it in the hard drives. And I don't need to compromise the software in order to get access to this data. All I need to do is, is to measure and extract the key that is used to encrypt this data. And if it's sent over the network, it's easy to tap into the wire and just log everything. And then once I get the key, I can take all this offline. And these devices can cost from $200 to hundreds of thousands of dollars. Let's put all this in context. If we're looking at a computing platform today, I want to take an example of a secure boot. With secure boot, normally we have the BIOS stored on in a flash device. When we power on the system basically acts as some sort of one-time programmable to say if the platform is in secure state or non-secure state. That tells you if you are going to do authentication and verify everything that is coming off the chip and make sure that it's okay. If we look at the previous slide, inserting a man in the middle like a malicious chip, that can cause code injection. And I can inject code that is not authenticated during runtime. So all these cache replacement method that are used and some of the processors will be vulnerable in this case because you don't authenticate every transaction and every time you have access to the flash. You authenticate it only once. So there is a possibility for code injection. If I'm more sophisticated and has something like a laser or can manipulate the frequency, I can try to skip some of the instructions that are executed. Some of them may be responsible for the authentication process that are done during secure boot. Maybe there are some protection tables that are used in order to allow prevent access to them to some regions. And laser injection can change this from 0 to 1 or from 1 to 0. All this in place, if I have a physical active, there is a lot I can do to um, disable all the security measures in place. Side channels also possible, even without having direct access to the platform. I can be within a few meters away, measure the electromagnetic field, tune my frequency. With enough measurement, you can extract that key. And once you extracted that key, you can do all the analysis and attack offline. So edge platforms are not the same as any other platform. Physical attacks can massively compromise and cause damage eventually. So the security measures that we have in place today need to change. Otherwise, we don't have that resiliency against physical attacks. Today in OCP security, we're working on defining these types of attacks and mitigation against them. If you are interested in joining this effort, please come and join us at OCP Security and help define those attacks and the protection measures against them. Thank you.
Hello, everyone. This is Ahmad. Please feel free to ask any questions in the Q&A section or in the chat window. I'm happy to answer any of your questions. So I'll be here for a few more minutes. If you have any questions, please write them down in the question and answer section or in the chat section. The first question by Gordon: are you considering physical access control and tampering as part of the solution? Yes, physical access control is part of the solution. However, it depends on the attack. So it depends on the measure for mitigating the physical access. So as I said, some of the attacks don't really need to open the box. Some of the attacks you just need to be present nearby, and you can do some measurement. If you collect enough measurement, you can crack a key and decrypt all the data. Tamper monitoring is a way to do it as well, but then you also need to guarantee that whatever monitoring method you're using is not being tampered with. So I think more here, rather than just applying detection, we're talking about the prevention by design. Are there any more questions? Thank you, everyone. If you need to reach out, please reach me at amada@nvidia.com. Thank you so much.